Hi, I would like to work question 24 from section 14. There were a few errors on this and I just want to make sure everyone's on the same page. So it is to let p of x equal x minus 3 quantity squared minus 4. And this was a matching problem where you had to match different parts of the graph to different components that are requested. So first of all, notice that this is a quadratic function in the vertex form. P of x is equal to a times x minus h squared plus k. From that form we know a lot. We know that the vertex, for instance, is hk. So for this function it is 3, negative 4. The other thing we know from the vertex form is that the value of a determines which direction the parabola opens. In this case, the value of a is 1. So with a being positive, that means that the parabola will open up. We know that the domain of any quadratic function is all real numbers, or negative infinity to infinity. Because the range tells us the y values, and we know that the graph has the vertex at 3, negative 4, and we know that the graph opens up from that point, the smallest y value, right, is going to go up. So the smallest y value is negative 4, and then it goes on up. So the range is negative 4 to infinity. The vertex we just stated is 3, negative 4. The maximum value, well, because the parabola goes on up indefinitely, there is no maximum value. The minimum value of the function, that is the smallest y value, and because the vertex is the lowest point on the graph, the minimum value is negative 4. And then we also have to find the x-intercepts. So recall that to find the x-intercepts, we let y equal 0 and solve for x. So we solve the equation x minus 3 squared minus 4 equals 0. We can do that by the square root property. If we add 4 to each side, we get x minus 3 squared equals 4. And then apply the square root property. So x minus 3 equals plus or minus the square root of 4, but that's plus or minus 2. Therefore, x is 3 plus or minus 2. So the x values are 3 plus 2, which is 5, or 3 minus 2 is 1. So the x-intercepts are 1, 0, and 5, 0. So if we actually graph that, we could plot a point at 1, 0, and at 5, 0, and then extend the parabola upward through those points. If we wanted to find the y-intercept, we could plug in 0. We weren't asked to do this, but 0 in place of x would give us a negative 3 squared, or 9 minus 4, which is 5, and so the y-intercept would be 0, 5. Let me know if you have questions on this. Thank you.